Hi, in this video we shall discuss about the limits. So what is the main intention to introduce the limit is, so I'll define it, why we need it. So the limit, the definition, the word, why it is required is, if you have a function like this, y equal to f of x, in order to talk about this function or in order to study the behavior of this function, the main problem is we should talk about all the values, or for every value of x what is the value of y. That is how we study a function, isn't it? In many applications, either in physics or mathematics or any other areas, whenever we talk about these functions, for every value of x we want to know what the value of f of x. From that we'll know how it is behaving, right? Now the main problem is, for some of the functions we will not be able to give a definite value for a function at some point x. I'll take an example quickly. Let us say y is a function y equal to 1 by x, which means f of x in this case is 1 by x. Now if you have to study this function 1 by x, we are supposed to talk about what are the possible values of this 1 by x for all values of x. But then the problem is, if we talk about the value of 1 by x at a point x equal to 0, it is undefined. The reason is, it is infinity. You cannot give a definite value. It is undefined, isn't it? Therefore, in that cases, since we cannot discuss about the value of x at a point x equal to 0, we talk about what happens in its neighborhood, which means we are not able to say what happens exactly at x equal to 0. Therefore, at least you should be able to say what happens in a at the values which are close to 0. Even though you are not able to discuss it at x equal to 0, tell me what happens when it is close to 0, either left side or right side. Now using those values I can approximate the value, what could be the value at 0, because we see in most of the functions, if we have to, in most of the applications we need the exact value of the function, but then clearly we will not be able to get the exact value of function. Therefore in this case, instead of going for exact value, we go for the approximate value. How do we approximate it? We just go into the neighborhoods and we check it. I'll quickly take an example, then you'll understand it better. Let us say I have f of x like this. I have f of x as x square minus 4 divided by x minus 2. Now clearly if you observe it, we cannot define the value at x equal to 2. At x equal to 2, obviously if you try to substitute x equal to 2 here, it is going to be in 0 by 0 form. Check it. 2 square minus 4, 2 minus 2. It is going to be in 0 by 0 form. Therefore, this function is defined at all the values other than x equal to 2. Let us say that is why this function is given this way, which means they don't want us to talk about x equal to 2, right? Then, since we don't have the value at x equal to 2, I want to know what could be its value at a value close to 2, right? So in order to find that, I'll use this factorization method. What is factorization method is, the very reason that we are getting 0 by 0 is because, see, whenever we get a 0 in this function and whenever we get a 0 in this function, it means that, when I substitute 2, it means that x minus 2 is a factor of this and x minus 2 is a factor of this. So I'm going to write it like this: x minus 2 into x plus 2 divided by x minus 2. I think you know how to expand this. I mean, x square minus 4 equal to this one. That is why I'm not writing it, okay? So now you can cancel it off. Therefore, f of x turns out to be x plus 2. Got it? Now we have got the function x plus 2. Let's call it y. So here y equal to f of x. So y equal to x plus 2 is what we got. Now I want to see how does this function x plus 2 behave. So for that reason, let us plot the graph. Let's see what happens for this. Okay, let us say this is x-axis, this is y-axis. Fine. Now y equal to, let's say x equal to 0. When x equal to 0, y equal to 2, which means when x equal to 0, y is equal to 2. This is the point, isn't it? This point is nothing but 0 comma 2, right? And similarly, when y equal to 0, x equal to minus 2. Let's say this point is minus 2 comma 0, right? See, from this I am just plotting the points. Therefore, the function f of x or y equal to this one x plus 2 behaves like this. Okay, it is point passing through these 2 points. Now how does this function behave at 2? At 2 it is not defined, isn't it? Therefore at the value 2, let's say at x equal to 2, let's say this value is 2, at this value it is not defined, so I am just putting a circle. So circle means it is not defined at that point, so we don't know what its value, it is hollow there, which means we are not talking about its value there. Now what we want to do is, since we are not able to say what its value is at x equal to 2, I want to know what its value might be when the value gets close to it, which means I don't know exactly what its value is here because it is not defined, the original function, isn't it? The transform function is giving us 4, that is okay, but the original function is not defining it. Now I want to discuss about what its value could be as we approach that point, right? Which means from left side as we approach it and from right side as we approach it, which means 2, not exactly at 2, but we are interested in finding out its value at the surroundings of 2, at the neighboring points of 2, right? And now those, if I find out what its value is at the left side and what its value could be at the right side, which means here and here, and if those two values turns out to be equal, then we can say that yes, the limit x tends to 2, f of x equal to that particular value. Then in that particular, whenever it is required, we can replace f of x with that particular value in all the applications. Okay, I'll just tell you what I mean to say here. See, now at 2 it is not defined, therefore I am not interested at 2, I am interested at a point which is very close to 2 but less than 2, right? So let me define for that reason a small number which is called x. Now x is a positive number which is infinitesimally small. Infinitesimally small means it is a very small number. Okay, let us, what is it? What is h? H is a positive number. Remember that it is positive number. Wherever I write h in this complete subject, it is a positive number, otherwise I'll let you know. Okay, so it is a positive number which is very small. Now I want to define the point neighboring to 2 which is to the left of 2. If you have to go to some value which is less than 2, then of course we have to do 2 minus h, isn't it? So what is 2 minus h? It is a point which is less than 2, which is very close to 2. Now I want to find out what could be the value of the function f in that point. That is also called as left hand limit. Why is it called left hand limit? Because we are actually coming from left side, towards the function. Okay, left hand limit of f of x at 2 is equal to limit h tends to 0 f of 2 minus h. So what is f of 2 minus h? See this, f of x equal to x plus 2, f of x equal to x plus 2, therefore in place of x I am going to put 2 minus h plus 2, right? Limit h tends to 0, isn't it? So what is that? That is limit h tends to 0, this is 4 minus h, which is nothing but 4. So what did you find out from that? So we don't know what its value is at 2, but then at a value which is less than 2, which means in the neighborhood of 2 from the left hand side, we are going to get a value of 4. Now let's see if the same thing happens on the other side also. If on both the sides the value is approaching to the same value, then we can say that probably the value of the function at that particular value 2 must be that. Let's see that. Now right, which means now I want to go from the right hand side. So I want to test the value of this function at a value which is to the right of 2 and very close to 2. Now what is that value? Obviously 2 plus h, where h is a very small positive number, right? Therefore let's discuss about right hand limit of f of x at x equal to 2, right? So that equal to limit h tends to 0 f of 2 plus h. Already we know that f of x equal to x plus 2. Then what will be f of 2 plus h? That equal to limit h tends to 0, f of 2 plus h is nothing but x plus h plus 2, isn't it? In place of x we are going to put 2 plus h, which means 2 plus h plus 2, which is nothing but limit h tends to 0 4 plus h, right? Now what is its value? Its value is going to be 4. Therefore, because you put h equal to 0 there, therefore we got that both the left hand side limit and the right hand side limit is both of them, they are both left hand limit and right hand limit both are equal, right? So since left hand limit and right hand limit both are same and both are equal to 4, we can say that limit x tends to 2 f of x exists and its value is 4. So it might look trivial. You might even ask me, why are you doing all this? You could even directly declare it here itself, but it is not that easy. It is, for this function I have taken a small function, a trivial function, just to explain you the concept. Later when I take big functions, then you will understand what is the difference and why should we be doing all this. Okay, for now understand the procedure. Later I'll tell you why we should be doing it. Now what did we find out finally? Finally we found out that even though for the given function the value of f of x is not defined at 2, we can approximate it to 4 whenever required. That is the meaning of it. So in most of the practical applications we cannot say the value of it is 0 by 0, go and put it. We cannot do that, because if you do this in numericals, let us say you got an equation which determines about the speed of a car, and now suddenly you got the value to be 0 by 0, right? And if you ask them to just substitute it there, it doesn't work there. Then what we do is, if its value is going to be 0 by 0, which is undefined, indeterminate, then what we try to do is we try to convert it to a close approximate value by using this method, right? That is why limits are useful. Okay, I'll take more examples and I'll make this point clear. Fine.